Hello and welcome to another Solana tutorial. Today I want to teach you some basics of terminology because every Solana dev should really know that and most of them don't. This is one of the things that many people don't understand, and there are some misconceptions about that because they didn't really learn about it properly. So today I want to shed some light on owner and authority and signer. Those terms, and they're super confusing actually because some people mean different things. I had conversations on Twitter with people how they name stuff, and that's not really consistent. For some things there are no proper names, but we want to be able to distinguish them, at least in our head. Even if we don't have the proper terminology that is consistent among the Solana ecosystem, at least I want you to have a proper mental model of those different things. So today I want to attempt to teach you what an owner is, what an authority is, because that can mean many things, and then a little bit about signing and who can sign for an account. Again, those things are very essential for a Solana developer to understand, and I hope that in this short video I can properly explain them. Let's dive into it. And we are going to start with what is an owner, because there at least I have a very clear definition. Let's check out some accounts. Every account on Solana has an owner. The owner is always written in the owner field of the account. So there is 32 bytes in every account that hold the public key of the owner of this account, which has to be a program. For instance, every regular account, every wallet account where you have the private key for it, or in this case, I have the private key for this one, the assigned program ID is the system program. So the Explorer calls it assigned program ID, which already starts our confusion with terminology. Assigned program ID is the owner. This is gonna be a horrible video, horribly confusing. Solscan, by the way, does call it owner as the system program. Not confusing at all. But yeah, that's my point. Different people or protocols, teams, explorers call stuff differently. It's just important for you to be able to map what they are saying to your correct mental model of what that means. So owner and assigned program ID should map to the same thing. You should know what people are talking about. Now, every account has an owner. Let's deploy our own program. I'm gonna manually grind myself something. 9F guy. Oh, that's a nice program ID. Our 9F guy is now our program. Cool. And we deploy that. Nice. We are deployed. So what do we see here? We deployed this program, which has an upgrade authority. We'll get to authorities later. And Explorer doesn't directly tell me the owner anymore because it says program account. So it abstracts that away. Here in Solscan, we see the BPF upgradable loader is the owner of this program account. Every account has an owner and it must be a program. In this case, this loader. So only this loader, so this program, is allowed to read or write to this account. Yeah, I mean, this is a good point to make that point. A good point to make that point. Lyrical genius. Getting big for that to demonstrate that this is important. Only the owner can change the data in the account. That's basically the Solana definition of the owner. That's the program that is allowed to change the data in the account. And changing the data means many things. It can mean subtract lamports from the lamport field. It can mean write arbitrary data into the data field, or even change the owner of the program. All of the fields of an account can be written to, except for the executable flag. That is special. I can't just set executable to any account. That's something different. Going back to the basics, that's what I was looking for. Each account has the following fields: lamports, owner, the executable flag, the data, and the rent epoch, which is not so important anymore because all of them are rent exempt per definition. And I said the executable is special, but lamports, owner, and data, those I can write to if I am the owner of this account. That's a core concept of the Solana programming model, that only the owner of an account can write to it. And that's so substantial. Like, if you understand that, then many of the things suddenly make sense why it is the way it is. Because only the owner of an account can write to that account. With the exception, actually, that any program can write to the lamports field as long as it's an addition. So the resulting lamports are higher than before, aka number go up. As long as number go up, anybody can put in lamports in any account. That's an exception. But in general, this field and this field, only the owner can write to. And owner, again, for me, has a clear definition in Solana. That's what's in this field of the account. In the owner field of the account, there sits the public key, is a program and can write to this account. Now, maybe we even go one step back and just create ourselves a simple account on Solana. How about that? Because I have also never done this before. When do you ever get to do that? Unless you're making a video about it. Let's create an account. I know, just some wallet, who cares? Wodgable. You go to DevNet with this key. Good. Then my key pair is every time the same. That's why I know this stuff by heart by now. There we go. One-liner. The system program has a create account instruction, which is fairly trivial to use. From pub key, that's the payer, so who is paying for that account? I'm gonna be paying for that account. Then the new account, so which address should that account live on? So I just create a new key pair, so a random address, and at that random address, I'm gonna create that account. Then I have to say, well, how much sol do I want to put on there? This is relevant for rent exemption, right? The more lamports I put there, the more data I can have. So actually the smart thing would be to go the other way around. First define the space. So how many bytes of data I want to allow for that account. Let's say in this case, I don't want to store data, so I put 0. Then my lamports are gonna be the minimum lamports for rent exemption. So Solana rent for 0 gives me that value. 1, 2, 3, 1, 2, 3. There we go. This in lamports is the minimum for a 0 byte data account, because the other fields, of course, also need rent. Remember those. Even if my data has 0 bytes, the others also require some space. And then that is the interesting part. That will be the owner of our account. Let's actually start with the system program. Good. Then we pack that in a transaction and send it. Important to note here though, when I'm providing the signers, I will also need to sign for the account key pair. And we're gonna get to signers for an account in a second. Why that is important? Essentially, it's to ensure that not everybody can just create that account, but only the one who is allowed to. And allowed to means they can sign for it, because otherwise the system program doesn't allow it. But I'll stop here because otherwise I'm getting ahead of myself. Lock the signature, check if that works. So simple transaction, which just called the system program, which just created myself an account. So it's just a create account instruction. That's the new address. And if we check out that account, then we see the assigned program ID, so the owner, is the system program. We don't see much more here. Funnily, and here's the thing, this is the exact same as if I would just transfer that amount of sol to an account. Let me show you. I shall now just, without even writing myself a script because I can use the CLI, Solana transfer, and now I pick a random account. Actually, I don't like random accounts. I still want to own it. Receiver, rej. So one more time. Solana transfer to that guy. And then we said that many lamports, and I think the CLI does it in sol. So we do that. Boom. Of course, we need to allow an unfunded recipient. That's just a CLI thing. And there we have it. Should be a very similar looking transaction to what we saw before, where again, we transfer from here to here. Just that now it's a transfer instruction and not a create account instruction. But really, that did the exact same thing. Why? Because every account per default is owned by the system program. So if nothing is written into the owner field of an account, then it stays all zeros. That's the default for all the data. All the lamports, the data, even if I allocate more space, the data will all be zero. And of course the owner, per default, it will all contain zeros as long as I don't write anything else into that. And which address per design, this is not random or luck, this is per design, that the system program lives at address 0. System program, address 0. 32 ones. Watch the video on base 58 encoding if you want to understand that. So, per default, every account is owned by the system program, as long as I don't specify another owner. And the difference between a system program transfer and a system program create account is that the create account will also change the owner. Just that we decided that we want the new owner to be the system program as well. We have decided that here. And obviously there are also other differences. The create account I can only do if the account does not exist yet. If I will run the same thing again here, I would need to run it on the same key pair. If instead of new key pair, I were to load account key pair, let's say is this. So if I wanted to create that account one more time, then the system program will complain and be like, hey, that account already exists. There are already lamports there. What the hell are you trying to do? Yeah, it will tell me a classic 0x0 that we know and love from our system program. That account is already in use. Whereas transfer, I could of course transfer another 0.0008 sol onto that account. There are more differences. But in this case, the transfer was very similar to the create account. Now, back to having an account being just another random address. What if we specified something else? For instance, well, that account that we just created should now be the owner of our new account. What do you think is going to happen now? I actually have no idea. I would assume that it works, but I can imagine that the system program checks that the program actually exists and is executable. But maybe it doesn't, and it seems like it doesn't. We have created an account with this address, the B5, and assigned it to this program, which, however, is not actually a program. It's just an account that is owned by the system program. So yeah, apparently the system program does not check for that, which is cool because you can then create accounts for a program that will exist at some later point. That's fair. But now that account is owned by this random address. So only that address, so a program at that address would be able to write to it. Generate a transaction instruction that assigns an account to a program. This would be what the create account also does, but once the account was already created. So we can create an account and then assign it to another program. So for instance, we can do the same account and assign it to the same stupid thing as before, which is not a program. But so that should be the same thing. First, just create the account, put some lamports there, and then we assign it to a different program. Add that instruction as well to the same transaction. So same result, we create a new account, which in the end is assigned to this program ID, which again is not a program, but we do it in 2 steps. First, we just create the account and then we assign the account to a program. So all that does is change the owner of the account. Cool. So far, so good. What if the account is already assigned to another program though. What if I then want to assign it to yet another program? Guess what's gonna happen? Is that gonna pass or is that gonna fail? I would imagine that it's gonna fail. It's gonna fail. Ha! Why? Well, because we don't own it anymore. And by we, I mean the system program. So, instruction illegally modified the program ID of an account. That's what happens if any program, including the system program, will write into the owner field of the account. They are not allowed to do that if they don't own it themselves. Even if that account themselves signed, well, like the account is like, hey, here's my signature, I own myself. The system program is like, no. Well, actually, the runtime is like, no, you don't own yourself anymore. You are now owned by this guy. Your signature is useless. So if it was already assigned to someone else, then the system program can't assign it anymore to somebody different. Why? Well, remember what I said before. Only the owner can change the owner field. Only the owner can write to that. And if the system program, which per default is the owner of all the accounts, that's why the system program also has this assign, because per default the system program owns it. But as soon as the system program doesn't own it anymore, the system program can't change the owner anymore. Now that program would need to change the owner. Does that make sense? So does it mean that we are completely screwed with those accounts that we created now? To test, let's create ourselves yet a different address. The lost account, lots. This guy, you are now my account key pair. I'm gonna create this one and not assign it here. So I'm doing the same thing as I did before. I'm just assigning my account to this other pub key. So an account that is owned by the system program, not actually a program, not executable. So that thing will never be able to change the owner field of this account. So my question is now, and I want to just find out for myself, is this account now lost, or can I still work with it in the sense of reassign it since I now have the signature of this one? No, that doesn't make any sense. I can sign for this one because I have the private key for this one. Which brings us, and let's get big again, to signing. As you remember from the basics of Solana programming, there are two types of signers. One for addresses on the curve, so where there exists a private key, that private key can be used to create a signature, right? So you have the private key, you take the entire transaction, you create a signature, so you do some mathematical magic, which then at SIG verify can be checked that you actually have the private key without you exposing your private key. That's simple cryptography for you. That's the one way. So here we need the private key. The second way of how Solana creates signers is with PDAs, where the program can sign by providing the correct seeds plus the program ID from within the program when it invokes a CPI. That's the second way to sign for an account. In this case, we're using the first one because we hold the private key. This is my private key for that particular account. And I'm fairly sure that when holding the private key, I can also make the system program transfer SOL even if the system program doesn't own that account. And that is something that I want to test now. I'll keep the same key pairs, my wallet and that account. And all I'm gonna do now is I will transfer from my account key pair that many lamports, so as many lamports as it has, and I'm just gonna transfer it back to me. Now, the account key pair can't transfer it out by themselves because they don't have enough funds. We talked about that in the previous video, or actually, I don't know if it was the previous one, but in the one where we were hacking the coin flip program, I did a lot on rent exemption as well. Check that out here. Yeah, so basically here I need to ensure that the fee pair actually is my key pair, because otherwise that's not gonna work. But like this, let's see if I can delete that account. Instructions spent from the balance of an account it does not own. Ha! Okay, so it is not allowed to do that. Nice! Nice. Okay, I also learned something because I thought that for some reason I thought that the system program can still modify the balances, but it cannot. It cannot. That's cool. Which also means that, again, referencing the previous video, actually here when we transfer from our treasury account, we actually have to do it like this. We have to borrow the lamports here. We couldn't even do it with the system program because we own that treasury account. So we couldn't do a system program invoke. It would have given us the same error. Cool. Learn something. So you have to do it like that. If you don't know what I'm talking about, watch that video. So nice, but that really means that what I said in the beginning is correct, even without the exception of the system program. Only the owner is allowed to change the data, the owner, or the lamports into the negative. Only the owner is allowed to do that. Which also means that this account that we just created, the LO, is really lost. Because I have no possibility of changing the owner, because this is not a program and this will not do it. And I cannot delete the account by removing the lamports. If there are 0 lamports on there, then it would get deleted, and that would also remove all the data in the owner field. By the way, that's also the reason why you can't reinitialize programs. However, what I actually could do is, since this one is still owned by the system program, I could remove this one. I have the private key for it, and I could actually deploy a program there, which would then let me write the owner field of the other one, or even subtract the lamports from. But that's a bit complicated. The nicer way would, of course, be if we created an account that would have from the beginning be assigned to our program. So let's do that. Should we keep us the private key? Because what I'm doing here is I'm creating private keys, essentially, signing with it, and then throwing away my private keys, which is common practice for a lot of things, like when you create a new mint or whatever, then you do that sort of stuff. Because as we saw, the private key is pretty useless once the account is owned by another program, unless the program needs that account to be a signer. Like the system program create account requires the new account to be a signer. The system program could be like, no, anybody can create any accounts and assign it to anyone. That would be a design choice, but it's not. The system program requires the signature. And as we also learned in the Solana development course, signatures don't really mean anything unless the programs check for them. So they only really get meaning if the program says, I only allow certain things if a signature for that account is present. And for some accounts, programs just don't check for the signatures anymore. Like for token mints, after the creation of the token mint, nobody checks for that signature anymore. So the private key can be thrown away because the signatures are only requested from the authorities for that account. But that again is getting ahead of ourselves. We're going to talk about authorities in a second. First, I still want you to understand the difference between the owner and the signer for a particular account. So I can make my account key pair a signer by providing the signature with the private key. Then it becomes a signer, and that will allow the system program to actually create that account. If I do not provide my signature here, if I wouldn't do that, then system program would complain and be like, hey, signature missing. There, signature verification failed. Because the system program requires that account to be a signer. So I need to give you back that signer here. If I sign for this account, then I can create it for ME. This is account for me. And this one is now owned by my program, which is an actual program. Nice. So this one could now change that account, change the owner or whatever. So let's actually do that. Let's actually demonstrate that. Return to system program. I could make it even more general. I could also call this assign. So we assign an account that we own to new owner. Again, I'm not gonna do best practices of Anchor development here. I just wanna get it to work quick and dirty. Obviously, you probably want to check those accounts that this is actually a program or whatever. But I'm okay if the transaction fails if I make a mistake. Don't do as I do, do as I say, is basically what I'm saying here, right? That account now, I can set the owner to new owner. Can I assign to data in the reference of? I can borrow data. But I cannot borrow owner. But there's an assign directly in the account info. That's helpful. Let's do that. So we have an account. I will do to account info and then .assign. That will do. Let's build and deploy. Find that account again that is owned by my program. That's the for me. Let's test this assign. So this account and the new owner, I want to be the system program. Okay, let's test that. Nice, that went through. So pay the transaction fee and I changed owner to system program. Amazing, I love it. Which means if I go to that account again now it's owned by the system program. The assigned program ID is again the system program, which means I could now transfer out the lamports with the system program by holding the private key. But I don't have the private key anymore, I threw it away. But I could, because the system program owns it again. So this is now a regular account again. Isn't that fun? And that, thinking like a hacker one more time, because I just think like a hacker most of the time. That could also be a strategy how you can get some data into an account that then another program owns. Because obviously I could write some data in there first before I give it back to the system program. Should we also do that? Let's quickly do that just to demonstrate. And I'm gonna grind myself another one with data. You are now my account keeper. And I don't know, I'll give you how many bytes? 16 bytes, who cares? And that's the amount of rent I would need to pay. And assign it to our program again. Space, I said 16 bytes, such that this time we keep access to the key pair again. Let's go. Now we see this account was created with 16 bytes. It has 16 bytes, holds a bit more sol, and is owned by our program. So that means our program can write stuff in there. And because I'm too lazy to make a separate function, I'm just gonna write it here. And it also doesn't matter what I write in here because the system program is not gonna read that anyway. But if I was attacking another program, then I could spoof whatever data I want to spoof. The point is just that our nice account that we just created, the DA, which holds data, I could now put that in here, the system program here, and then execute. Oh no, instruction illegally modified the program ID of an account. Am I not the owner? But I am the owner of this. Now suddenly this is illegal. Why? Does the runtime not allow that if it has data? Smart. We are learning something about owners. That's cool. Maybe I cannot change the owner of an account if the account actually holds data. I mean, the system program managed, the system program allocated this account, which I own, to the system program. This time it passed. Aha! So maybe it actually checks for data to be 0 before it can change the owner. Wow, that's actually quite cool. So this worked that I change it back to the system program. Now the system program owns it again. And now we can actually kill that account again with our signature. Because we can copy that amount and be like, Solana, transfer, I don't know, where do we transfer to? Back to our wallet, who cares? This much as my DA whoever. Oh, I think that's the same thing as with minimum for rent. But I've written a script for that. It was the delete account. I just need to put in the right values here. Just take this account key pair and sign with this one, then it will work. Interesting. The system program doesn't allow a transfer because the account must not hold any data. Interesting. So actually I would have had to do that with the program itself, that I also clear out the lamports. Cool, I keep learning stuff. Anyway, so back to my deployed program. If I now, actually I'm just gonna assign it back to the program. I'm just not gonna create the account, but just assign it back to the program. Yep, that will do. So it's not owned by the system program anymore, but by my program. Nice. Okay, I'm gonna leave that instruction the same, and I'm gonna do a write, which just takes the account and I write data to it. So if I now write data to that account, test that, that works. So I can write data to it. We've changed the data to whatever. If I now assign back to the system program, now this fails because it says illegally modified the program ID of an account because there is data on there. So that's the difference. If I write it back to 0, now I gotta build and deploy that again. Again, I cannot assign it unless I write 0 to the data and then I can assign it. Cool, I learned something. Nice. So I can only change the owner of a program if the data is zeroed out. Otherwise, apparently the runtime doesn't allow me to do that. Cool stuff. Okay, so that was about the owner of the program and about the signing. If I wanted to delete that account, delete. Let's see if I remember how that worked. Try borrow mutable lamports and double deref that and set it to 0. And maybe I should remember the balance. I like that you have the Rust analyzer here in Playground. I love it. So I can't just delete that. So I need to have another account, a receiver, where I actually add the balance. Otherwise this won't work. Will this work now? Question mark? No, of course not. Why not? Well, because we don't even own that account, so we are not allowed to subtract lamports. Instructions spent from a balance of an account it does not own. That's another one of those runtime checks. I can't just do that because I don't own that account. At the moment, the system program owns it. So I gotta reassign it back to me as we did earlier. Now I own it again, and now I should be able to do that. There we go, now it passes. And we can look at that transaction. All of the sol was removed. Wait, here. All of the sol was removed from this account. It was transferred to this account, but we don't really care about that one. And that means that this account is now deleted, aka it does not exist. So it has 0 bytes. That's the way how we can clean out an account. That works for all accounts except for programs. When it was once executable, then I'm not allowed to, I actually don't know if I am not allowed to kill the account or if it's somehow, but somehow I can then not reinitialize it at the same address. So I think program accounts, they stay active even if you kill the program. Like with token mints in the TokenProgram program, you can't delete the mint. But anyway, that's a different story. So this account doesn't exist, which also means per default, the system program owns it. So I didn't assign the system program anymore, but since I deleted that account, it's now back to 0 with all its data and also the lamports and of course the owner. So that means now I can start fresh and I could create that account again at the same address, maybe with different space or whatever, right? But now this will work again. And I could once again create that account and it wouldn't say 0x0 because the account doesn't exist. Now it does. Cool. But important to note here again, in order to do that, to create that account here again, we once again needed the signature. So we needed to sign with this key pair. And we could do that because we had the private key still. So that is the second area that I want you to learn about. The one thing is the owner and the second one is who can sign for that account. So every account has an owner and every account, there is some means to sign for it. And so far we've been discussing the first one, private keys. Before we discuss the second one, I want to give you a definition of the authority so that you can keep all of those concepts in your head and then maybe it's easier to distinguish. An authority. Hold on. Let me find us something. We've already seen an authority. Our program, for instance, has an upgrade authority. Some public key with which signature I can update the program. So let me get big again and attempt to do a general definition of authority, but this is way more difficult because there's no standard written out way where it's clear. Most of the time when we're talking about authority, and what I'm talking about here, the authority for an account is some other account that can sign on behalf of our account to achieve certain things on that account. Concrete example to make it more grabbable, practical, understandable. This program account has an authority, which is another account, the pub key of some user, where there is a private key for it, so that that address can sign transactions. Only the account owner can change this account. Who is the account owner of a program account? The BPF loader program. So the BPF loader program owns this account. So only that program can change the data of this account. So that BPF loader program gets to decide who is allowed to write to that. Well, it gets to decide when it's writing to it or not, right? So in a way, it decides who gets to write to it. And that who is usually a user wallet and not an account. I mean, we could have structured it in a way where always that account itself needs to sign for the program to update. So we always need to provide a signature for that address such that I can update my program, write to this program account. However, that is way less flexible than if I specify an authority who can do it instead of this account themselves. This allows for changing the authority, and it means that we don't need to keep the private key for this address super safe, right? Once the program is created, once we provided the signature for the system program to create us the account and assign it to us, or assign it to the BPF loader, we can basically throw the private key away. That's also why we can use vanity addresses and stuff for programs, because the only thing that we need to keep safe is the authority, because the program is written in a way such that it will only allow changes to this account if the update authority provided a signature. So this guy suddenly needs to sign in order for the BPF loader to allow writing to that account. Because remember, only the BPF loader can write to that account, and only if it finds a signature for the authority will it actually do it. Otherwise it will error. Invalid upgrade authority. So not everybody can just update my program. And that's the idea of an authority. It's different to the signer. I mean, it signs for transactions. The authority does sign, but it signs for itself. So this, in the list of accounts in that transaction, this one will have the signer flag. So this one will provide the signature, not the account itself. So the authority of an account is another account that then provides the signature to do something with my account. But it's different to who could sign for the account itself. Did I confuse you all right? Maybe let's do a practical example in our program so we hopefully understand it a bit better. Shit, I'm already at 2 hours recording again. I thought this was a quick little video. There's no quick with me. Let's go to our program. How do I call that? Program account? Terminology is always so difficult. I don't know, let's just call that the user account, which can hold some data. More importantly, there will be an authority. That will be my user account. And then we do a create account. And this time we'll do this properly. Proper typed accounts, as you would properly do that in Anchor. Such that we can then easily set the authority to the user's key. Perfect. So that's all that's gonna do. Store the authority. Now here again, I'm ensuring that the user is a signer. So I, as the program, I'm checking that only if the user signed will the user be allowed to be the authority. That's important that the program checks that. And then what else am I going to do with that account? I'm going to just init it. That's the anchor way of doing what we did here. It's just doing a CPI to create account on the system program, such that we don't manually need to do this. Am I forgetting anything? I feel like I'm forgetting something. Oh, I'm forgetting the system program. That's what I was forgetting. I knew there was something that I'm forgetting. Also, I'm forgetting that I need to have you mutable, because otherwise I can't pay with you. So, but now that's better. Okay. So my create account requires a user account. Can I here provide a random address that is also a signer? Will you then make that a signer? Random binar da sounds like a song. You could probably sing that public key. Bina uda six. Okay, then it gets complicated. But anyway, the user, yeah, my address, why not? My address in the system program, it fills in as the system program because it's smart. Let's test that. Function does not exist on chain. I did deploy it, right? Too bad I couldn't create the account that I could sing. There we go, that's better. Okay, so the 89x, we have created that, and same as before, it's a system program create account instruction, just that it's now a CPI from within my program. So we invoke the system program. It's not a separate instruction, it's a CPI. But then it also just did the same thing. Plus, it wrote data to that account. So this one, in its data, somewhere there are 32 bytes that represent the authority. So that's not a specific field inside the native account, but it's inside the data that I define that some of the bytes here represent a public key that is the authority for that account. And why is that authority important? Well, for stuff like change data or whatever my program would do. We set the data to the data. So far we didn't win anything, because if the program doesn't adhere to the authority, then the authority is pointless. If I don't do a check that this user account's authority is actually a signer, then anybody can write to any accounts, because all of those user accounts, all of those accounts are still owned by my program. And as long as I own it, I can write to it. But the authority makes sense to check that only the correct user is allowed to write to that. The concepts with the authorities we use such that we can, do authorizations. The public keys to the authentication, and we as the program to the authorization. We say only this person is allowed to do it. And the signature makes sure that this person is actually who they claim to be. So authentication and authorization. But we need to make sure, simplest way for me to do this is to create this has one check. Oops, wrong way around. Here, I need to do this has one authority. Then it checks that user account dot authority is the authority key here. So I'm just going to rename my user to authority. Then that works with this simple one-liner here. I could also do a more general constraint and say user account dot authority equals user. But with this, if I just name it correctly, that will also work. So only if there's an authority present in the user account and it equals the key of this signer who has to have a signature present, then do I even allow for this instruction to be called, or for this execution of this instruction. Signer checks and authority checks and owner checks. Also, Anchor does owner checks here. If I specify user account is account, then Anchor also checks that what I'm putting in here is actually owned by my program. So this account is owned by this address. Anchor also does checks on that. So here we have an owner check, here we have a signer check, and here we have an authority check. Those are three very important terms and can be very confusing because that signer is different than who can sign for that account. And do we then call that the authority of that account? Not really, just a signer. Well, we'll get there. Now, this guy, we can throw away the private key for this, right? We said we just need the private key to create the account, and we see that actually this one was a signer as well. So the private key was provided, the signature was provided by signing with the private key. And now we can basically throw it away. We don't need the private key anymore because the account is created and there is an authority set who basically now takes the role of the signer of the account itself, because now basically only if this guy signs do I allow to write to this. Again, it might be a bit confusing to get behind that, but once you understood it, it's actually quite simple. Right, so let's demonstrate this change data instruction. This should not be anything too new to you. It just illustrates an authority. Oh no, did the build fail again? Oh wow. Oh, I forgot. Of course we don't init this anymore. That's another copy paste error. For a long time I had it there and you didn't even notice. Or did you? Then congratulations. I didn't notice. We created it here and we change it here, so it's just mutable. We don't init it anymore. Okay, sorry, my bad. So we can now change the data for this account. Data, I don't know, who cares? And the authority, this one needs to match what is stored in the authority in this account. So if I put here a random address, then a has1 constraint was violated, because this has1 checks that the authority corresponds to that signer. And if it doesn't, then my program is like, no, 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 no. I don't allow this. So I need to provide the correct authority here, and that was my address. I was written into the authority field, and if I execute that, then it will work and I can change the data. So that's the authority. Another address that can sign, which in the program gives it some privileges, some authority over that account or associated accounts, right? So we now understand those three things. What is the owner of the program? Let's go through it. Here, this account. What is the owner of the account? Well, the program that can modify its data. Who can sign for this account? Well, whoever holds the private key for this address. At the moment, nobody anymore. We threw that away. And then number three, who's the authority for that account? That's a concept that's just relevant in relation with the program. This program gives this account some privileges if some other guy signed for. And that authority, we don't see it here because it's written somewhere in those bytes, but we know it's the NDA. Only if this guy provides the signature can I, for instance, call this instruction. Now, finally getting back to the second way how we can sign. Remember, because for now we were just talking about the private keys, the first way. PDAs are the second way. And I also at least want to give a quick example for that, because that's where it then gets confusing for some people. Because they usually compare the signer with the owner, which is often the same, but doesn't have to be. Let's do an example. So we do another create account, but let's do create PDA account. So we're gonna do the same thing as here, just that we also provide some seeds and the bump. Here we go. We now also provide keys. So essentially we don't need to provide the signature for this account anymore, because our program will indirectly supply the signature through a CPI where it provides the correct seeds. So let's demo that. I can now create a PDA account where I need to say from seeds, because that needs to be matching this thing, otherwise it won't work. So first is a string user, and second is a pub key, which needs to be the address from the user. So here I'm just gonna go with mine again. Also gonna copy that in here, generate the PDA for that. So that's the correct PDA then. And that's just the address. I don't have the private key for that. And I can test that. There we go. also worked. This time without supplying a signature. So this guy was not a signer, it's just writable. But my program did a CPI, and here this guy was a signer. So to the system program, it looked like this guy was signing, but only because our program provided the seeds for this account. Let's go through the three things again. Who is the owner? Well, still my program. Who can sign for it? Well, that's different now. My program, if it provides the seeds, user, and the key of the authority, then it can sign again for that account, because this is now a PDA of my program. But note how this could be different to the owner. Usually when we say it's a PDA of that program, program derived address. The program derived that address. We derived that address, remember, we derived it with our program ID. But that does not mean that the owner is also the same program. And then the authority, again, is this NDA. So inside the data, there we find 32 bytes that represent the public key of this NDA who signed here in the beginning. We set him as the authority. Owner, signer, authority. Three different things. And the point I wanted to make with this entire video is mainly this, among other things that I hope that you learned. The owner doesn't need to be the guy who can sign for this account. It is often the case, as it is now, that the owning program is also the owner of the PDA. So is also the PDA creator. So this PDA was derived using the same program ID as is the owner for the account. But we can, of course, assign this account to a different program now. Well, now not anymore, because we've written stuff in there. If we now try to assign this account to, I don't know, any random address, this won't work. We're illegally modifying the program ID again, because this address contains data. We would first need to zero it out, like we would need to delete it. We could also do that and have the receiver be a random address, who cares? But then still, we cannot assign it, because now we don't own it anymore, because now it's owned by the system program. So again, we're modifying an account that we don't own. But what we can do is derive a PDA and then assign that to some other program. That's a valid thing. Let's also try that. Let's do an assign PDA. That should now initialize this account, and then in the actual instruction we can assign a new owner. So let's assign a PDA, which also creates the PDA. So the naming is probably not ideal. That account we now need to take from seeds, PDA and my pub key, and we derive it with my program. This is who will be able to sign for it, my program. But the owner will be different, because the owner we will set to a random address there. JAE, why not? Let's see. Let's pretend this was some other program. This has worked. Look at that. And now look at that account. We see the assigned program ID, aka the owner of that account, is some other program or random address that doesn't exist yet. And now it is different. Now, this is a PDA of my program, but the owner of the account is someone different. And that's how far I wanted to get you with this video, that you understand this difference. Because usually if we say the owner of a PDA, we mean, well, both. We mean the program that can sign for this PDA, and at the same time, we mean the program that owns the account. But that can be two different things. That's my lesson that I wanted to bring you in those 3 hours. Well, hopefully just one if I edit it down. They are different. So my program can sign for an account that is owned by another program, and some other program could call the create account instruction of my program and just provide the user account a PDA that other program derived. And to me, it looks like a normal signer, so I will accept it in my program. And the program could also set its PDA as the user, that it has the authority, then it can sign for that. And the funny thing, it can do both. This could be the same address. Here, it could create the user account at some PDA address, and the user, so the signer, could also be the same address. So we set the authority to itself. So then those two things are the same, the authority and the signer. But the owner will be my program. And that's where it gets like pretty confusing to some people maybe. I kind of want to do that now, but I also noticed that this video is already very long and this is pretty much an edge case. But yeah, that's how programs are supposed to do token mints. Set the mint to a PDA that I control, that I can sign for, then I just need to provide one account, the token mint, to the transaction. Because the mint is the same as the mint authority. And that's the same as here. I could have that account also be the authority for that account. Because that PDA can sign for it. But the other program doesn't need to own its PDA. Okay. Lots of theory. I think I want to end it here. I could demonstrate, but you could also just believe me that that's how it would work. Very last thing, because the token program is so prevalent on Solana that you can't really get around it, and I want you to understand what's happening at the token program. Let's have a look at a token. Yeah, why not? Let's create a token. Let's SBL token, create token, and I'm not gonna get myself a vanity address, but there, the AXJ, that is my token now. Let's have a look at that on chain and look at those three things that we just learned about for our unknown token. Question 1. Who is the owner of this account? And this account is the token mint account. Yeah, token mint. Who is the owner of it? That's correct. It's the token program. Explorer doesn't properly display this because it says this is a token mint, so for Explorer it's clear that the owner is the token program. Let's see if Solscan is a bit more verbose on that one. Yeah, it says owner program, so it's really making that distinction between token owner or authority and owner program. This is the token program. So the token kek, the old token program, the normal token program, the first token program, whatever you want to call it. This is the owner of this account. That's clear. That's owner. Who is the signer of this account? Well, whoever has the private key for this one. And this time, because I didn't create myself a vanity address, the CLI just created a new key pair, created that token, and then forgot about the private key again. That's usually what happens when you create a new token just with a CLI. Nobody is the signer anymore. And also with the token kek, the signer is pretty pointless because we can't delete that account anymore anyway, because the token program owns it, and the token program didn't implement closing mint accounts. So that token will forever exist on DevNet now. That was the second thing, the signer. Third thing, the authority. Now, there can be more authorities. The most relevant one for a token is the mint authority, so who can create tokens. And this is my wallet, my public key. Only if I sign the transaction, the token program allows to mint tokens for this token. But then there's also another field, the freeze authority, which is none at the moment. But if I create another token where I enable freezing, there the B, so we have an A and the B token, BPF, nice. Then for this token, there's not only a mint authority, but also a freeze authority, which is also me. So both of the fields within the data of this account, so in the state, the mint authority and the freeze authority are specified. So that's the third thing, the authority or authorities. Again, one account can have several authorities for several things, because that again is just a concept of the program. The program needs to define who needs to sign when doing what. The whole authority model is just a program thing. That's not native Solana. It's not part of the accounts model or whatever. Whereas the owner is, and the signer as well. Right, so that's for the mint account. Let's create ourselves a token account. SBL token create account. And I'm gonna create it for the first token and for myself. I'm gonna create an ATA for my wallet and this token that will result in this account. Let's check the transaction. There, this account was created. I paid for it. And we already see that not only did we use the system program to create the account and the token program that is assigned to, we also kind of used the associated token program and the mint. But let's look at that account and go through it again, because this is where the terminology here gets a bit confusing. Who is the owner of this token account? No, it's not the owner of the token account, because that terminology is just bad. Really, the owner, so the owning program, the owner program, what does Solscan call it? You literally don't even display that. Okay. But is on curve false, so this is a PDA. Yeah, the owner, I can spoil it to you, is the token program, because the token program will need to modify the balance of this account, right? And that's also just data. So in order to modify the data, the token program needs to own that account. So all of the token accounts are owned by the token program. What is the owner here is really the authority, the transfer authority. It's some other address that, when it provides the signature, is allowed to transfer out tokens. So the token program ensures that only if a signature of that authority, of that token account owner, only if the signature is provided, will it transfer out tokens or close the account or whatever else you can do with a token account. So this is actually what I like to call the transfer authority. They just happen to call it owner, which makes the whole thing a bit confusing. So we had the actual owning program, we had the authority. Who is the signer? Who can sign for this account? And here it becomes a bit more relevant, because token accounts can be closed, so they can be zeroed out. There is a close instruction on the token program. That's how you get the rent for them back. That's how my fee redeemer works. One of my first Solana projects. All it did was closing token accounts. And if a token account is closed, then there are 0 lamports on it, and then it's deleted. So it can later be reinitialized. So it can be created again. And to create it again, you need to be able to sign. Otherwise, the system program doesn't allow you to create it. That's what we saw in the beginning. So who can sign for this address? What's your guess? Is it the token program? No. The token program owns this account, but it cannot sign for this account. Also, the token program doesn't need to sign for that account the same way it doesn't need to sign for the token mint, because the token program owns it anyway. It can do whatever it wants with that account. But who did derive this address then? Which program? Well, let's have a look at that transaction. Maybe we see it. The instruction was called on the associated token program. The associated token program did a create instruction. And that then CPI'd into the system program to create account, where it created this account. And this, the system program here requires the signature. So here the calling program, so the associated token program, already provided the signature for that by providing the seeds. And then it directly assigned it to the token program. That's where all the interesting stuff is happening. And then the token program initializes that account for that mint and owner. So that's then token program stuff. But yeah, the interesting part is here. The associated token program, it can sign for this address, because this address is a PDA that is derived with this program address, the associated token program, a token. And if you don't believe me, then you can look into how ATAs are derived. They are derived with the associated token program, but I leave that for you as homework to look into if you want to. For me, I think this is enough. This is enough from me. I'm signing off. Thank you for watching this video. I hope that I could get some clarity on the terminology of owners, signers, and authorities. I mean, it sounds so trivial, but it's not. But yeah, after this hour of watching this video, I hope that by now you understand at least what the owner is and what privileges the owner program has, what the concept of an authority is, and that not every PDA of a program is actually also owned by the same program. If you learned those 3 things, then I'm already happy. Give it a like, subscribe, enjoy other videos, and I'll see you in one of my next ones. Till then, bye bye.